Hello there! We are SKA Robotics, a division of Student Space Association of Warsaw University of Technology.
We're a team consisting of mostly undergraduate students. Out of 37 members, only 2 are PhD candidates and 6 members are getting the master's degree. This year, we present to you the series program. The work in the project is divided among the team members on the basis of work breakdown structure, where each task is split up into the most basic assignments, which aims to facilitate the division of labor, as well as helps coordinators track the progress and solve any problems on the levels they occur. Based on our experience, such division yields measurable results, is easily implemented, and most importantly, is straightforward in interpretation and assignment of duties. The team has been divided into 4 sub-teams: mobile platform, equipment, electronics, and software and autonomy, each with a designated leader, responsible for monitoring work progress and organizing team meetings. The CTO coordinates dependencies among systems. The CFO oversees all external orders and controls the available budget. The project leader sets a work schedule, deals with sponsors and ERC organizers. The main goal of the students' associations is gaining and exchanging knowledge. The best way to achieve this is by taking part in various challenges, such as European Rover Challenge. It gives us the opportunity to significantly improve our rover design and its configurations. Other than that, we are able to present ourselves and get to know the different teams that work on similar projects. By comparing our achievements with others, we can analyze our work and improve it to reach the best possible results. Additionally, by participating in ERC, we can promote our university, our association, and the space industry overall. This in turn will help us increase the number of engineers in future generations. With this more, the atmosphere at the event is truly unforgettable, and in itself it's a great reward at the end of many months of hard work. The idea behind Series 2 was conceived in the middle of the COVID pandemic, and its main assumption was to be able to use the time we had during isolation to focus our attention on a new project and get through those difficult times. We knew perfectly well that it would not be easy, as the world did not seem to be coming back to how it was. What we feared the most was the difficulty in getting the materials, specialized parts and services we have to outsource. With that in mind, we designed the next generation of our rover to be quite similar to its predecessor. We opted for evolution rather than revolution. The additional benefit of that was the ability to test features implemented in Series 1 right before the dawn of the pandemic, but never formally tested during a challenge. What is more, such backward compatibility mitigates the likelihood of not having a functional rover ready to compete in case of any external factors we are not able to control. Unfortunately, the obstacle that we were not able to overcome was financing. At the end of last year, we applied for a grant program of the Ministry of Science and Higher Education called Koła Naukowe Tworzą Innowacje. In February 2021, we received the confirmation saying we got it. However, as of today, we have not yet received the fundings. As a result, we were forced to postpone already prepared orders of mechanical components. Fortunately enough, owing to our design, we were able to install and test the new electrical system and communication, as well as software and autonomy, on the previous platform. We have implemented multiple independent safety systems in our rovers. Due to the fact that the motors are very powerful, there was a need for software limits on rover velocity. Moreover, the rover should operate autonomously. Therefore, it signals every action beforehand to prevent any dangerous or unpredictable behavior. For that purpose, we use an industrial-grade lamp, and additionally we provide detailed status in the operator's panel. In case of loss of communication for a substantial amount of time, the rover will autonomously stop. Furthermore, should any of the crucial parts of our rover software fail or serial communication with the motor's drivers break, motor's power will be cut off. The final, yet critical, safety system is the emergency button, which turns off the main contactor and cuts off all power, resulting in an instantaneous stop. The Series rover is controlled by a proprietary system based on the ROS framework. It allows us to run pieces of the software on multiple machines, like rover's onboard computer and ground station. Furthermore, it ensures stable data transmission. For connectivity, we utilize 2 wireless networks in 2.4 and 5 GHz bands. Interface for remote control of the rover is implemented as an extension set of RQT plugins, which are responsible for processes such as manual driving, autonomy configuration, control and live visualization of crucial data. Operators are also provided with feeds from cameras on board the rover, which ensures that the rover can traverse safely through the environment. Our autonomy subsystem uses multiple means of localization to guarantee high precision. We use data from the inertial measurement unit, wheel encoders, and cameras, as well as localization features of the Z camera. The Series rover can autonomously cover complicated paths consisting of many segments. For this edition of the ERC, we decided to approach the science task mainly using a spectroscope designed by one of our members. Thanks to its functionality, we'll be able to precisely determine the chemical composition of rocks and minerals encountered during the challenge, without making any major changes to the environment, leaving it almost unaffected. The analysis of the collected data would provide us with an insight into the geological history of Mars. For what consists of the future of our science section, we plan on building an ellipsometer which would allow us to measure the chirality of organic matter, if such were to be found near the hypothetical landing site. With such a device, we would take our ability to analyze data from the red planet to the next level. We've still got a lot of opportunities to grow. Our heads are full of new ideas on how to improve and develop. Hopefully, in the years to come, we'll be able to execute our plans and learn a lot on the way.